Assalamualaikum and hello friends. Today we will start with a new paper of October number 2025, paper 1, variant 1. So let's start with the question number 1. Question 1 says, what is the electronic configuration of the particle aluminium carrying plus 1 charge with the atomic number 13 and mass number 37? So let's start with the electronic configuration of an aluminium having no charge on it. It simply has atomic number 13. 13 atomic number means 13 electrons. So for 13 electrons, the electronic configuration becomes 1s2, 2s2, 2p6, and 3s1. So they are 13 electrons without any charge on it. But if it has a plus 1 charge present on it, then it means one of the electrons will be removed, and we know it is a electron to be removed from the last shell. So third shell is the last shell, so it will be removed, which means the remaining electronic configuration will become 1s2, 2s2, 2p6. And for this reason, the uh, the electronic configuration. Along with that, one more thing. It is not just 3s1, it is basically 3s2 and 3p1, right? And then this is for 13 electrons. Now the electron will be removed from the last shell, so from the last shell and from the last subshell. So 3p is the last subshell. So electron will be removed from 3p. So which means the remaining electronic configuration is 3s2. So B is the correct option. Now our next question, number 2. The data in the table gives the fifth to 10th ionization energies of the three elements from period 3 of the periodic table. Now we have three elements. We have to identify which of the element belongs to which symbol. We have three elements X, Y, Z symbolized. We have to identify which of the element X it would be out of these four elements. So here we find that among the elements in the first table, we have to identify the difference, the large gap for the ionization energies. So for the element X, we can see that if we move across the sequence of the ionization energies and say the difference from the fifth to sixth ionization energies, there's a large gap. And then in the Y element, we can find the large gap is from sixth to seventh ionization energy. And for element Z, the difference, the largest difference is existing between 7 to 8 ionization energies. So in this way, we have properly the large gaps. We remember if the large gap is between 5 to 6 for the element X, then it would mean element X will have 5 valence electron. It will have 5 valence electron in the outermost shell. Similarly, if there is a large difference between 6 to 7 for element Y, then it will carry 6 valence electrons in its valence shell. Because the lower value of the 2 is the actual value for the valence electron. Lower value is basically indicating the number of valence electrons. So we can see that for the Z element, there will be 7 electrons. So for electrons, we can also identify their group number. If the element has 5 valence electrons, it will mean it will belong to group number 5. If the element has 6 valence, it will be present in group number 6 and group number 7 for the Z element. Now we identify from the lower table, element X would have 5 electrons, which means it must belong to fifth group. So if you check from the periodic table, we can see that phosphorus is the element in the group number 5. For the element Y, the element sulfur is in group number 6. And from element C, the chlorine is present in group number 7. So these three elements have three ticks. So that's why the correct option becomes the option C. Question number three. What contains 9.03 into 10 to the power 23 oxygen atoms? So for this purpose, we must remember the relationship that 1 mole is equal to particles of the Avogadro's number, 6.02 into 10 to the power 23. So we simply have to multiply the moles with Avogadro's number. But for that purpose, you must also look at the formula. So aluminum oxide formula is Al2O3. It will carry 3 oxygen atoms, which means the number of moles present in aluminum oxide is 0.25. And for oxygen atoms, it will be 3 times of that value, 3 times of 0.25. So this is basically equal to 0.75. So 0.75 mole of oxygen, and it will be multiplied with the Avogadro's number, which is 6.02 into 10 to the power 23. I can write over here, it is equal to Na value. Okay, similarly do for the B part, sulfur dioxide. So sulfur dioxide is SO2, which has 2 oxygen atoms, and the moles for sulfur dioxide is 0.75, or multiply with 0.75, so it will give you 1.5 into uh, Avogadro's number. Then for sulfur dioxide, it is SO3, and for SO3 we have 1.5 multiplied by Avogadro's number of oxygen atom, which is 3. So it is equal to 4.5 into Na. And lastly, we have water, H2O. There is just one atom, so 3 times 1 is equal to 3 moles of the oxygen atoms into Na. So the only value which will be equal to 9.03 into 10 to the power 3 will be the multiplication between the 1.5 and Avogadro's number. So if you multiply this value, you will be getting 9.03. It is equal to 9.03 into 10 to the power 23 Avogadro's particle. So B is a correct option. Now question number four, methane and steam react to produce hydrogen. We have been provided the message of methane and the steam. We have to calculate the volume of the hydrogen gas. For this purpose, we must use stoichiometric calculations. First of all, just use the values provided in the message over here and also calculate the molar masses. So molar masses for the substances mentioned, one is a methane, the other one is a steam, and the third one is hydrogen. Molar masses, as you know, is basically the mR multiplied by the number of moles. So multiply mR of the molecule with the number of moles. That will give you the molar mass. So for let's suppose methane, we know it's just 1 mole, and the mR of methane is 16. So it will be simply 1 times 16. So it is 16. And for water, it is 2 times of the 18, which is equivalent to 36. And for hydrogen gas, it is 4 times of 2, equivalent to 8. So these are the molar masses, 16, 36, and 8. And the other values which are mentioned, 0.80 gram for methane, 1.35 for water. Now, we are supposed to find the volume of hydrogen gas. So first, we will be calculating the mass from the ratio method, and that mass will be converted into the volume by by first calculating the number of moles. So I'm going to take the ratio method here. The ratio method is for the first of all between methane and water. So I'm taking a ratio between them. Methane is CH4 ratio the hydrogen gas, methane and hydrogen gas. So I will first use the value of molar mass value, which is 16 for the methane, and for H2, it is 8. Then I take the value from the provided value, 0.8 gram for the methane, and this time the value of hydrogen become X. So then do the cross multiplication. So the value of X will be equivalent to 0.4. It is equal to 0.4 gram. So 0.4 gram of hydrogen gas will be produced. I'm not moving forward right now to calculate the mole and then to calculate volume because I still do not know which of these two reactants is a limiting reactant because it says one of the reactants is used up, which means one of the reactant would be a limiting reactant. And that limiting reactant will produce lesser amount of the hydrogen gas, and that will also produce less amount of the volume. So let's move on to the next part of the same question, that is do the ratio method between the water or steam versus hydrogen gas. So H2O ratio hydrogen gas. So molar mass of the water has been calculated to be 36 and hydrogen gas is equivalent to 8. Then use the value for the steam provided, which is 1.35 gram. So 1.35 ratio. Now mass of the hydrogen has to be calculated for X. Then do the cross multiplication. So if you calculate the value, it will be equal to 0.3 gram of hydrogen gas. So this shows less amount of the hydrogen gas is produced if we compare with the steam. So just use this value for in the remaining calculation. First, you calculate the number of moles of the hydrogen, which will now be equal to 0.3 gram according to this value divided by the molar mass of hydrogen, which is 2. So it is equivalent to 0.15 mole, 0.15 mole of hydrogen. And we remember the relationship between the volume of the gas versus the mole. 1 mole of a gas at room temperature and pressure is equivalent to 24 dm cube, which means 0.15 mole will be equivalent to, just do the calculation, it will be equivalent to 3.6 dm cube. So 3.6 is a correct option. B is a correct answer. Now the next part, question number 5. Which statement explains why sodium and potassium had different melting points? Okay, so here we remember sodium is a metal and phosphorus is a non-metal. So we need to relate with the attractive forces present in the metal as well as non-metal. Whenever we are supposed to explain the melting point or maybe the boiling point, you need to relate intermolecular forces for the non-metals. And we remember there are three intermolecular forces which we had discussed in course. One is the identity forces. The other one is the permanent dipole forces. And the third one is hydrogen bonding. The third one is hydrogen bonds. Always mention these three intermolecular forces if you have to discuss the non-metal. For the metal, you will simply relate with the metallic bond. Metallic bond must be related for the metals. And if you have ionic compound, let's suppose ionic compound or ionic crystal, whatsoever, you have to relate with the ionic bond. These will be related for the melting and boiling point. So we read the first sentence. The attraction between the cations and delocalized electrons is greater or stronger in sodium. That is correct. Why metal will have a higher melting point or boiling point? They have although not provided you the values, but we remember metals would definitely have higher melting point for the small small molecules because the potassium, yes, potassium, sorry, potassium is a metal again, yes. Uh, it's a slight mistake. I misconfused with the phosphorus. Potassium is also a metal. So why there is a difference between sodium and potassium? You have to relate with the metallic bond only. The intermolecular force is related for the non-metals, not for the metals. It's just for the non-metals. So sodium versus potassium will definitely have a difference of only metallic bond, and we can say a metallic bond is attractive for between the cations and the delocalized electrons. So that will be stronger in the sodium. That's why it will have the higher melting point. Beach states the attraction between cations and anions stronger in sodium. There is no anions in the metallic bond, so this word is wrong. The option C, the attraction between atoms is stronger in sodium. There are no atoms. There are no, these are neutral. This is this atom word indicates a neutral charge. So there are no neutral atoms in the metallic bond. They are rather cations present. And the option C, the attraction between nuclei and shared electrons is stronger in sodium. So there is no kind of the covalent bonding. This sentence means covalent bond, but there are no covalent bonds in the metals. So that is also wrong. So that's why the only correct option becomes the A option. Question number 6. Ammonia and HCl react together to form ammonium cyanide and ionic compound, which row states the number of coordinate bonds. So if you remember that we have the dative bonding between ammonia and hydrogen ion, which we studied in the course. So it will form the ammonium ion NH4 plus. And the structure of ammonium ion that I can show you through my notes. So here you can see that when we discuss the formation of the ammonium ion, there was a dative bond formed here. And you can see this is the dative bond with the arrowhead over here. So in a similar way, you can find the dative bond in the given question. So in the question we have in similar way, but that is for the H, the hydrogen is coming from the HCN. So instead of that, we will write NH3 reacting with the HCN to make the compound NH4CN. In a similar way, this HCN is providing the hydrogen ion and Cn negative ion. That's why there is a ionic compound. This is the ionic compound because this ammonia in a similar way forms the NH4 plus and the Cn becomes negative ion. So anion and cation, they have the ionic bond between them, and that is why this is basically an ionic compound. Now we have to tell the number of coordinate bonds. So definitely, just like in the topic of ammonium ion, we saw there was one coordinate bond. So one coordinate bond will be present here. So if you again look at the structure of HCN, in the HCN, this is the compound of HCN from my notes. You can see all these details here. So here we find the carbon to nitrogen has a triple covalent bond, and in the triple covalent bond, we have one sigma bond and two pi bonds. So similar C and bond will be there in the question. So in the question, we have a similar type of the bonding of the CN, which means there will be two pi bonds. So two pi bonds are there. So for this reason, the correct option becomes the option B. Now, question number 7. When 1 mole of ethanoic acid in aqueous solution is dry, so we have to justify why the reaction is exothermic. So if you remember the topic from the O levels, when we discussed that delta H is basically equivalent to bonds broken. In simple way, you can say energy absorbed or required. The energy is all required to break bond minus energy released when new bonds are formed. When bonds are formed. So this is the same terminology used here. And according to this, direction is exothermic when we'll say that the value of the energy released will be higher. It will be higher value as compared to the energy that is taken in when the bonds are broken to break bonds. So its value will be smaller. In other words, broken value broken value is less than the energy released, and that's when the value will be negative. Answer will be negative. For this reason, D option is the correct option. Now, question number 8. In an experiment, 1.6 gram of a fuel is burned, 45% of the energy released is absorbed by 200 grams. So we just do the calculation. We have this formula Q is equal to MC delta T. That's a simple formula which you have to put here. The values, mass, over here, this mass belongs to the mass of the water. So here we have M equal to 200 gram of the water used. The C, the constant, is heat capacity, which has a constant value 4.18, which you can find from the data section of the paper at the last of the at the end of the paper. And delta T is basically TF minus TI, which is, I can write here, delta T is equal to TF minus TI, final temperature minus initial temperature, which is 66 minus 18, and it is equal to 48 degree. You do not need to convert the values into Kelvin and then do the difference, because it is simply a temperature difference. Whether you take in centigrade or in Kelvin, that will remain the same. You do not convert the values of centigrade into Kelvin. Now put the values here. Mass is 200 gram. C value is 4.18 and delta T is equal to 48. Now the answer of this calculation will be equivalent to 180, 18057.6 joule. So this is value for this much. But it says that 1.6 gram of the fuel was burned. How much energy is released when it is per gram, which means you need to take a division by 1.6. That will give you a value of joule per gram. This value belongs to 1.6 gram, but we need in the value of 1 gram, which means 18057.6 divided by 1.6. So this is now equivalent to 25080. It is just closer to this value, 25100 is just closer to, but this is not the final answer because it says that only 45% of the energy is released. How much is the energy, total energy released? We need to convert the value for 100%. So just do the simple ratio method. We can say that 25080 amount of energy was released when it was just 45%. How much energy will be released and become X when 100% of the energy is released. So when you do the calculation, X will be equivalent to 25080 times 100 divided by 45. So the answer is 55733, 55733, which is just closer to the answer given in option B. So B is the correct option. Question number 9. Sulfite ions react separately with zinc and with magnesium dioxide, and these are the equations. Which numbers are correct? So just put the numbers randomly and you get the answer. We put the numbers of the A option first. So according to that, it says that A is 1 and B is 2, then W is 2 and X is 4. Now check whether this could be the correct option, which means they are one sulfur on the reactant side, but on the product side, they are two sulfur. So definitely this cannot be balanced. The equation cannot be balanced in this way. Uh, Even if you put 1 over 2 over here, it will still not give you the correct values for the rest of the atoms. So without going into that calculation, you can easily check that the sulfur is not balanced according to this combination. And we can see in the table below that both option A and option C, they have exactly same combinations for the first equation 1 and 2, 1 and 2. So that means A and C both are incorrect. Now look for the other combinations. According to this, the option B says B and D both have same combinations for the first reaction, 2 and 2 for A and B, and then the difference lies between W and X. In the option B, we have 2 and 4. So W becomes 2 and X becomes 4. Now check whether you do not need to check the first equation because it is already just go look at the second equation. So the four hydrogen ions can only be balanced with this water by multiplying four hydrogen atoms. So it is mixed SO3 2 minus sulfide ions, and from MnO2 we also have two oxygen atoms. So 2 plus 6 is equal to total 8 oxygen atoms on the reactant side. Now check on the product side. On the product side, we have 2 times oxygen 2 from here, and over here, if you just put 1 over here, it will give you 2 sulfur atom, which is already balanced with the left side, 2 sulfur and 6 oxygen, so 6 plus 2. So that is also equal to 8 oxygen. So you can see that by using the combination B, it gives you the correct balanced equation. So that's why The correct answer becomes the B option. And if you try to balance with the D option by exchanging the W and by exchanging the W and X with 4, 2, you will not get the balanced equation in terms of the number of the oxygen atom. They will be unequal on each side, on either side. So that's why B is a correct option over here. Question number 10. Which equation shows hydrogen acting as an oxidizing agent? So here you just need to use oxidation numbers. There is 0 on the hydrogen in the reactant side for all of these gases, 0, 0, 0 for all the hydrogens. But what about the product side? We have -1 in the A option, and in the B option, the H and I, they almost have similar electronegativity values because you can tell which of the element will be negative and which will be positive only on the basis of electronegativity values. You remember that if you go down the group 7, the electronegative values changes from 4.0, highest for the in the periodic table for the fluorine, then 3.0 for chlorine, and then it further decreases. On the other side, hydrogen has electronegative value of 2.5. We can expect that the value of the iodine and that of hydrogen will be very much closer to each other. So for this reason, Hi is considered to be almost non-polar molecule. There is almost no charges present. So we cannot understand, we cannot tell there will be any kind of oxidizing or reducing agent in the B option. Then about C option, in the C option, the hydrogen has +1 state in the water. For one hydrogen atom, it is +1, and it is 0 on the reactant side. So it is getting oxidized. It means hydrogen becomes reducing agent in the C option. So it is reducing agent in C option, and in D option, it's the same thing. In ammonia, nitrogen is -3, and hydrogen, for one hydrogen atom, it is +1. So it is again a reducing agent in the D option. But in A option, we can see hydrogen is -1 and it is reduced, which means hydrogen becomes the oxidizing agent over here. So that's why A is a correct option. Now, next question number 11. In 11 gram of nitrogen gas stored in 2 cube vessel, 40 degrees centigrade, what's the pressure? So simply we use this formula, PV is equal to nRT. Rearrange this equation to find pressure, which is nRT over V. We need the moles as well because the mole value is not provided. So use the value of, so convert the formula of mole into mass over mR, which means mass into R into temperature divided by N is basically mass over mR because nitrogen gas is given, which means N2. So mR times volume. Now mass is 1 gram, volume is 2 decimeter cube, but the pressure is in Pascal. We remember the equivalence of volume and pressure. If the pressure is given in Pascal, then the volume must be given in meter cube. This is the equivalence between them. And if the pressure is given in kilopascal, then the volume should be given in decimeter cube. So I will convert this decimeter cube into meter cube. So divide with 1000, you get 0.002 meter cube. And this temperature is converted into Kelvin. So 273 plus 40, it is equal to 313 Kelvin. Now put the values here. Mass is 1 gram. R is general gas constant, 8.31. Temperature is 313 Kelvin. Mr, which is nitrogen, so Mr of nitrogen is 28. So 28 over here. And volume is 2 decimeter cube converted to meter cube, 0.002. The value which you get after calculation is actually 46,446.96, and this value is very much closer to the option C. These values is closest to this value. So we select the option C here. So that's the correct answer. Now question number 12. This question is basically a repeated question which I already solved before. We can see the question is taken from May, June 2015. So here, what we basically did, we first took the equilibrium expression of this equation. According to that, this is the equilibrium expression. And then you put the values. So value for the HbO2 is basically equal to 1.9 into 10 to the power minus 6 divided by the 1.96 into 7.6 into minus 8. So what we have here, we have, so let's attempt the question. Uh, the statement says one molecule of hemoglobin bind with 4 molecules of oxygen. So we take the ratio over here. We have Hb ratio O2. So Hb will be equal to 4 molecules and O2 is 1. According to this statement, 1 molecule of hemoglobin bind with 4 molecules of oxygen. Sorry, 4 molecules of oxygen means 4 molecules of O2 and 1 molecule of Hb. And we already given the value of the concentration of O2 over here, which is 7.6 into 10 raised to power minus 6. For this case, we need to find how much concentration of hemoglobin that will be, that becomes X. So you cross multiply it, the answer will be X is equal to 7.6 into 10 raised to power minus 6 divided by 4. So it is equal to 1.9, this much, 1.9 into 10 to the power minus 6. So this is done. We have calculated the value of the Hb. This is the value of Hb. And according to the equation, we have a 1:1 between hemoglobin and its compound. So just put that expression Kc is equal to Hb, concentration of Hb, just like over here, done here. Expression of Hb compound divided by Hb and O2. But we remember there are 4 molecules of O2, so the power will become 4. And we already calculated the value of Hb, that will also be the value for the Hb compound. But for Hb, uh, for Hb, it will just be this 1, and for O2, the value of the concentration used from the statement, so that will be power 4. So when you do the calculation, you get this answer 3 into 10 to the power 10 to the power 20. So A is the correct option. So A is the correct option over here. Now, question number 13. Aqueous acid P and aqueous alkali Q have this same concentration. Okay, so first of all, we identify what would be the substance P. Since substance P was initially added to the conical class and then Q was added into the same class, which means this is the P over here and then Q was added into the P. So we can see the starting line of the graph is somewhere at the stronger acid range. So strong acid is the P compound. So from the column P, ethanoic acid is not a strong acid. So we are left with option A, B, C. And when Q was added, the equilus point is exactly at 7 because you can consider this is a totally midpoint of this vertical line. This is the midpoint or the vertical line, which is somewhere around 7, pH 7. So pH 7 is equinox point here. So that means it is basically a strong base here. Q will be a strong base, which is take to the feet make to give this sharp vertical line. So Q cannot be a weak base. So we are now left with option A and C. Now we have to select what could be the of base, whether sodium hydroxide or barium hydroxide. Now, if we look at here, we have two informations to check this. First of all, it says that 20 cm cube of the acid of the P was used, and this vertical section is at 10 cm cube. It is not at 20 cm cube, which means HCl was 20 cm cube, but the Equinus is at 10 cm cube. It is basically the half of the 20. So half of the 20 is giving you 10 cm cube, which means it is that point where both the hydrogen ions and hydroxide ions were exactly the same. And it says aqueous P and Q have the same concentration, which means their volumes are also the same. Or you can say mole to volume ratio. Here, barium hydroxide have 2 moles over here, 2 moles of the hydroxide ion. So we can see that if the hydrogen ion is 20 cm cube, but the base, if it is base is NaOH, then it will also have 20 cm cube. Both will have 20 cm cube, and they will be giving you equalence point at 20 cm cube because both are equal in volume. But the equalence point is 10 cm cube, which means they were in actually 2 moles of the hydroxide ion present in the solution, 2 moles of the hydroxide ion. But the hydrogen ions was just 1 mole of the hydrogen ions was there. So to make it equal, you had to take a half of these 2 moles of the hydroxide ion, which is present in barium hydroxide. That means the compound was barium hydroxide, which had 2 moles of hydroxide ion. So if it was also 20 cm cube, we had to take the half of that to make it equal to the mole of hydrogen ion. So half of 20 is equal to 10 cm cube. So 10 cm cube of the barium hydroxide ion, sorry, barium hydroxide compound was reacting with the 1 mole of the 20 cm cube HCl. That's why you get 10 cm cube over here. So that's why C is the correct option. Now question number 14. We have to verify which of the statement is correct. So 14 state in A option, it says Cu plus and Cu2 plus acts as catalyst. So we can see that copper ion is reacting here and here it is produced. Copper plus 1 ion is both reacted and produced. So yes, it works as a catalyst. It is a catalyst and Ce2 plus is produced here and it is reacted here. So it is again catalyst. So Cu plus 1 and Cu2 plus both are catalyst. That is correct. But even then we verify the other three statements. B says Cu plus ions act as an oxidizing agent in reaction 2. So if it is has to be the oxidizing agent, then it must be reduced. But if you look at the equation, it is being oxidized. Cu plus is converted into Cu2 plus, which means it is not working as oxidizing agent, rather it is acting as a reducing agent. So that is incorrect. C say reaction 3 increases the darkness of the glass, but here it says darkness of the glass is because of the silver atoms. But in option C, in reaction 3, we see it is forming Ag plus ion, the ionic form of the silver. So it does not darken the glass. So that is also incorrect. Statement D says silver atoms are reduced, but silver atoms are not reduced, rather they are oxidized. So that is also incorrect. So that's why the only correct option is the option A. Question number 15. We have to tell whether the catalyst is following these two statements. What direction? The sulfuric acid is a homogeneous catalyst. So if it has to be a homogeneous catalyst, then both the reactant and the catalyst must be in the same physical state. We can see it is a reaction between a methanol and ethanoic acid. Both are liquid form or aqueous solution, we can say. And the sulfuric acid is also the liquid form or the aqueous solution. You can either say liquid or aqueous, both mean the same. So for this reason, statement one is correct option. Statement two says the sulfuric acid lowers the activation energy of the reverse reaction. So catalyst purpose or catalyst performs its action by lowering the activation energy and gives an alternative pathway. So this is the effect of the catalyst, and gives this for both the direction for the forward as well as the reverse reaction. But here there is a problem. I do not agree with this word reverse reaction. It should be reversible reaction. It should be reversible reaction. It should not be said as reverse reaction. There is my uh, I have a strong conservation over here that the word is not correct. It should be reversible word here because if you go to the mark scheme, the correct answer written is A. A is the correct option in the mark scheme. But if you follow the word reverse, then according to that, statement 2 becomes incorrect because catalyst does not just lower the activation energy of only one direction, rather it decreases for both directions, forward as well as backward. Both are lowered in energy, forward and backward. Backward has a second name of reverse. So for this reason, I do not go with this correct with this incorrect word. It should be reversible if it is reversible, and if it is reversible, then the correct option becomes the A option. So that's the mistake by the examiner. They have not correctly used the correct word here. Nevertheless, you will go with the option A if it says the marksum says A. And if you just consider on the reverse direction, then in that case, the correct option will become B, B, because one will be the correct option and second will not be the correct option. All right, so question number 16. The atomic radius and ionic radius of the three elements are given in the table. We have to select the element. So atomic radius, if you remember the trend of the atomic radius across a period, then you can see from my notes that across a period, the size of the atom decreases. This is the atomic radius trend. This is the atomic radius trend across a period. And you can have these three graphs just for this one purpose, the atomic radius. And the trend of the ionic radius is this one. Cation size decreases and anion size of the same period, have higher radius. The ionic radius of anions is greater than the cations of the same element. Sorry, of the same period elements. So, this is about the radius and anion and cation size. And whenever cation is formed, its size decreases, and whenever anion is formed, its size is increased. Now back to the question. We have X, Y, Z, three elements. Now, if we look at their sizes, we can clearly see that Z has the highest size, then comes X and Y the smallest. So Z is larger in size than Y, and Y is sorry, Z is larger in size than X, and X is larger in size than Y. So this is the trend of these atomic sizes. And if you look at the ionic radius, it can tell you which element will be a metal, which element will be a non-metal. Because we remember that metal loses large shell to convert into the cation. So element Z is changed from 0.160 to 0.072, which means it is forming the cation by losing the large shell. And the element X is changing from 0.11A to 0.056, which means it is also forming the cation by losing the valence shell. But the element Y, it changes from 0.099 to 0.180. That means the size has increased. So the increase in size indicates that element Y is forming the anion. So from here you can tell element X is basically uh, one thing to be sure that the element size decreases from left to right. Size decreases from left to right, which means this would be definitely a metal because we have seen metal size as reduced by forming the cation. And Y is definitely a non-metal. Y is definitely a non-metal because it forms the anion, and anion formation is the property of the non-metals. We cannot clearly tell whether the X is a metal or a non-metal because here it shows cation formation, and we remember uh, the group 4 has both the property of forming the cation or anion. It can form both kind of the anions. If it forms cations, then size will decrease. If it forms anion, then size decreases. That's also apparent in these notes. We already said in the group 4, the group 4 is silicon. So silicon can be forming plus ion or it could be forming negative ion. So it is up to the type of the reaction. So here in this case, you can see the silicon has formed the cation. Now we look at the options. The options are element X has lower electrical conductivity than element Y. So what is the trend of electrical conductivity? For this reason, you can see from my notes, uh, these notes are available in the Google Drive link mentioned just below this video in the description section as well as in comment section. So this is the electrical conductivity trend. These are the two graphs for this purpose. You can see sodium has least electrical conductivity than magnesium, and then highest goes to aluminum, and then it drops to silicon, and then further to drop to phosphorus. And in this graph, it is steadily decreasing from silicon till green. So if we say the metals, they have higher electrical conductivity, and non-metal like phosphorus, sulfur, chlorine, they have the very least electrical conductivity. And silicon is also having very less electrical conductivity than metals. So back to the question. If we say that X is basically somewhere in between case, then X has lower electrical conductivity than element Y. So Y is already a non-metal. So that is not correct. Y cannot have higher electrical conductivity than X. So A is incorrect statement. B says element Y has higher melting point than element X. So element Y is already a non-metal on the right side of the periodic on the period 3. So Y cannot have a high melting point than element X because if we look at the melting point trend, this is the graph for the melting point. So we can see non-metals have a lower melting point as compared to the metals. Sodium, magnesium, aluminum, these three are metals. So they have higher melting point comparatively to the non-metals, phosphorus, sulfur, and chlorine. So that is also not correct. B is also incorrect option. Then C says element Y and element Z react to form an ionic compound. So yes, when we said that Z is basically a metal and Y is definitely a non-metal, so they do react together and they form the ionic compound because ionic compound is formed by the combination of a metal and a non-metal. So that's why C is the correct option. And D says that Element Z forms ionic compound by gaining electrons. So no, Z is a metal. It loses electrons. It does not gain electrons. It has to lose electrons. So that's why it is incorrect. Now, question number 17. Three equations are listed. X, Y, and Z are all whole numbers. Which equation can be balanced? So just put the values over here. X should be 4. So put 4 in all of these options. And Z is 2. So put 2 in all of these options. Now check but which of the equations can be balanced. First equation 4Al, and on the right side 2 times of Al with 2, 2 times Al2, so 4Al, and oxygen 3 on the right side, 2 times of 3, 6, so make 3 over here. So in this case, in this way, oxygen is balanced. So first equation is balanced. Second equation, 4 mg on the left side, but on the right side is 2 mg, so it is not balanced. And third equation, 4 times of Na is balanced with the 2 times of Na2 on the right side balanced, and O is 2 on the right side, so just put 1 over here, so that also balances it. So equations 1 and third both are balanced. So in this way, A is the correct option. Now question number 18, which oxide has a simple structure rather than a giant structure? So we remember MgO is an ionic compound, so it has a giant structure. Aluminum oxide is also a giant ionic compound, and SiO2 has it is basically also a giant structure. You can have all of this information from my notes, as I mentioned before. The Google Drive link of this notes is already provided in the uh, data in the description section. And in this page, you can have all the information of this chapter, and we can see the oxides with the type of the structure. So giant ionic for the magnesium, for the sodium oxide, for the magnesium oxide, giant ionic, aluminum oxide, giant ionic, silicon oxide is giant covalent. And the phosphorus, P4O10 or P4O6, whatever it is, P4O10 or P4O6, it is simple molecular. So this is the only compound in the given options that has a simple molecular structure. So that's why D is the correct option. Question number 19. We have to verify the trends. So A option says radium has the highest second ionization energy. So if we go move down the any group, it could be group one, group two, group three, group four, whatever group it is. Then moving down the group, the ionization energy does not increase, rather it decreases. Ionization energy decreases down the any group, decreases any group, decreases down any group. So A becomes wrong for this reason. Radium hydroxide is the least soluble. So if we tell the hydroxide trend, then hydroxides of the group 2 down the group solubility increases down the group. This is the trend. So radium hydroxide is not least soluble, rather it's the most soluble. So this word is wrong, least soluble. C says radium carbon has a lowest thermal stability. Now with respect to carbonates, the thermal stability of the group 2 carbonates down the group increases. Thermal stability increases. And radium is very much down the group too, because remember that trend, beryllium, magnesium, calcium, strontium, barium, and then radium. Radium is the lowest element or the lowest position. So its thermal stability is highest, not lowest. So this is wrong. And then D says radium reacts faster with water than other element group 2. So yes, moving down the group 2, the the reaction of the element increases. The reason was because of the weaker metallic bonding down the group 2. As the size increases, size of metal increases, so its reaction with water increases, and that's why the hydroxide form is also more soluble. So that's why D is the correct option. Now, question number 20. Equal masses of these compounds are thermally decomposed, which will produce the greatest volume of the gas. So, if you have to recall the decomposition, we remember that metal carbonates decompose to give the metal oxides plus carbon dioxide. So, it will form the calcium oxide plus carbon dioxide. Similarly, barium carbonate will also produce the same barium oxide plus carbon dioxide. So there is just one gas produced here. But in case of the nitrates, there will be three products. The calcium oxide plus the nitrogen dioxide plus oxygen gas. Similarly, for barium, option D, barium oxide plus nitrogen dioxide plus oxygen gas. So we can compare that carbonates are producing just one type of the gases, but nitrates are producing two type of the gases. That means definitely nitrates will have more volume of the gas produced. So both option A and option C becomes incorrect since less amount of gases are produced. Now what could be the reason? What could be the difference between B and D? So here we need to relate to the thermal stability. As we said before in the previous part, the thermal stability uh, so we can say that the compound which has more stability, it will produce less amount of the gas. Since barium nitrate is more stable, BaNO3 volt-wise is more stable than the calcium nitrate, then the volume of gas produced by the barium nitrate will be lesser as compared to the volume of the gas produced by the decomposition of the calcium nitrate. So that's the reason B option is the correct option. So we justified it by the trend of the thermal decomposition of the nitrates. So we have done 20 questions of this paper. We will attempt the remaining question in the next class. So stay tuned and subscribe to my channel and stay tuned for the remaining papers of all the components and all the variants of October number 2025. So that's all for today. If you have any question, any queries, you can reach me out on my WhatsApp number or you can drop your message in comment section. Till then, take care and bye bye everyone.